little bit about my background. I'm currently a developer advocate at Red Hat, mainly focusing on Go and Kubernetes. So Go in the context of APIs and interacting with the Kubernetes API server. Before that, I was a developer advocate at Mesosphere, doing obviously more Mesos than Kubernetes, but a little bit of Kubernetes as well. Before that, I was a data engineer at MapR, doing a lot of big data stuff around HDFS and HBase and Drill and so on. And the reason why I'm in Ireland is because in 2008, before the crash, there was still plenty of money available to pull in researchers, and that's where I moved here to Galway, actually. Did some 4 years in the research institute there. Nowadays, I'm mainly using Go, but I've been using Python and Node and Java and C++. I started out as a C++ developer. I was young and needed the money. And yeah, I would call myself a developer turned operations guy, more or less, or appops in that sense. Enough about myself, a little bit about you. Who is an admin? Show of hands, please. Admin, sysadmin, nope, okay. Site reliability engineer, kind of, nope. Developer, okay, cool. QA, in case you don't know what it stands for, you don't need to know. Quality assurance, like, you know, making sure the stuff has high quality, no, okay. Architect, no architects around, cool. Product or project management, no. Pointy hairy boss, no, okay. And the rest of you are here for the pizza and beer, or? Okay, so apparently we have some other roles than developers, which I failed to list here. That's interesting. Okay, so the entire talk assumes that you're either a developer or have some idea what developers typically do, because the whole point is to make sure that in a microservices setup that you are equipped with the right tools and methodology to be successful. So let's talk about containerized microservices. Obviously, you can do microservices without containers, but it shows that it's a really great way to package and deliver microservices. And it's a nice match also in terms of granularity. A little bit about terminology, that we're on the same page. So when I talk about containerized setup, I really mean effectively Docker and Kubernetes in a nutshell. I'm going to come back to that in the tooling section, but on a high level. There are other options as well, but more or less Kubernetes is nowadays the standard in the industry. We're going to talk a lot about observability, and that essentially means on a high level that at any point in time you're able to have the insight what is going on within the microservice or between microservices. When I say troubleshooting, I mean essentially looking into an application or microservice that is running and you need to fix something. When I talk about profiling, that is typically more in an earlier stage where you're trying to optimize a certain path. For example, you see that the response time, the P90 of a response time is too high, so you need to figure out which microservice causes the main delay there, and then you optimize this part, for example. If there's anything in terms of terminology or any questions, please do shout out. I'm not sure if we have a microphone. I see a microphone over there, but given that we are recording, you probably want to take the microphone and talk into the microphone. So don't hesitate to stop me at any point in time. I'd rather have you asking right away than waiting until the very end. Any questions so far? Not the case. Cool. So let's have a look at what happens when you develop and deploy a good old monolith. You start out with version 1. And then a long time later, weeks or months later, you release version 2. And the whole purpose of this exercise here is to motivate the rest of the talk, trying to convince you that because in a microservices setup you're dealing with a different kind of timeline, you as a developer, in a developer role, you will need to learn or to interact with operational aspects. So first step is let's split this monolith into 3 microservices. This is obviously a gross simplification. In a normal setup, you might end up with 20, 30, 50. Netflix is reported to have hundreds of microservices. So 3 really is a symbolic number here standing for many microservices. And again, for the sake of argument, let's assume all of them start with version 1 here at that point in time, and they're released at the same time, which is again a simplification. But even with that, in this simplified case, moving forward in time, you see that the person or team that is working on the microservice 1, due to whatever reason, does not release a new version at that point in time, only microservice 2 and 3. And that goes on. The third iteration, these two microservices release version 3, and the first team releases version 2, and so on, and so on, and so on. So at a certain point in time, you're effectively dealing with different versions of the microservices, and you can't really predict the dependencies there. You know the dependencies, who is calling whom, but you can't really assume that everyone else is more or less in the same state or is using the same kind of interfaces there. So the loosely coupling here comes with a couple of implications that you need to be aware of. The other thing that is obvious, that if you compare the timeline monolith 1 and version 2 versus the different versions of the microservices, that you're obviously iterating way faster, and because you can release all of them independently, you're much more flexible, right? There might be a good reason why that takes longer, but that doesn't block all the others, right? So that is a huge advantage in terms of developer agility and being able to deliver features very fast. So far, that looks like microservices are awesome. You should always be using microservices, but there are challenges around that. The first challenge has little to do with microservices, to be honest, but is really around, if you look at the incentives, how are developers paid or motivated versus operation folks. A developer typically is motivated and paid according to how many features she or he actually delivers, right? So getting features out as fast as possible, which means a lot of change. On the other hand, operation folks, their primary objective is to keep stuff stable as long as possible, right? Every change that you introduce potentially means something breaks. So these incentives are really opposite. Now, with a monolith, you typically have this throwing over the wall, and there's little, looking back and little cooperation there. With microservices, it kind of feels more natural that as a developer, you're thinking more and respect the operational bits more, and actually you're almost forced to. Another thing never to forget is that any kind of microservices application is actually a distributed system, and there you have to deal with the fallacies of distributed computing. I've linked it here if you want to have a look at the slide deck later on. And that means essentially you can't just assume that you have the same kind of communication paths as a monolith where everything runs on the same box. So the microservices communicate with each other. They might potentially run on different machines, but even if they run on the same machine, the communication path there might be, packets might be dropped, the whole thing might be split into halves, and so on and so forth. There are many things that can go wrong and will go wrong. And there are different schools of thought how to deal with that. One is more dealing with stuff or asking developers deal with stuff that's things like, you're using a library, a language-specific library that deals with that on the microservices level. And there is another school of thought that argues, well, there are things like service meshes and so on that essentially implement that kind of behavior or help you with that, and including instrumentation outside of the application, and the developer doesn't have to be aware of that. But at the end of the day, no matter which one you subscribe to, you have to deal with it, or someone has to deal with that. The number one thing why I still think that if you're if you have a great culture around a monolith in terms of developers and ops folks working together, is exactly that one. At the monolith, it's always clear where to look. It's that one piece of software, which is not the case with microservices. That sounds, in the first place, it sounds like, well, that's not a big deal. I just need to look, where's the problem? But sometimes you don't know. You just see, the response coming in, something happens there, And then you need to figure out which of the microservices or which of the interactions or whatever actually causes a delay or an issue or whatever. So really the biggest advantage of the monolith in this setup is I always know where to look. It's a huge code base, but at least I know exactly where it is. I don't need to figure out, pinpoint, this is the microservice or container or whatever, where I need to look at. Okay, let's move on to actual tooling so that we get a bit of a feeling what is available in that space. I mentioned already earlier on, to me, microservices typically means microservices using containers, and containers nowadays essentially means Kubernetes. Who is not familiar or aware of Kubernetes? Everyone heard about that? Cool, then we can make that one short. Essentially, it's all about container lifecycle management. So being able to launch a container, find a node where to run it, and manage the entire lifecycle, including health checks, rolling updates, and so on and so forth. It has a declarative and state-driven API, which is also very extensible. So you can, even if the resources don't match your concrete workflow or workload, you can extend it without needing to extend Kubernetes core as such. And it's quite robust and flexible. Scalable nowadays still means up to a couple of thousand nodes, and with the current infrastructure in terms of the service level stuff, maybe tens of thousands of services before you actually see issues there in terms of congestion. In terms of developing on Kubernetes, so from a developer point of view, there are a lot of tools, and I'm not really going to go into any details, just give you an idea that there are many things that you can potentially look at. Some of them are smaller scoped, some of them are bigger scoped. At the end of the day, you probably also will want to prioritize stuff given the environment you're working in. So for example, if you're on Google Cloud, you probably want to have a look at Scaffold. If you're on Azure, probably Draft from Microsoft is more for you. If you mainly work locally, things like Ksync or Minikube, Minishift, or Docker Community Edition on the desktop is a good option, and so on and so forth. Just to give you an idea, there are plenty of tools out there, and next week, if you keep an eye on the Kubernetes blog, there will be a blog post. Colleague of mine from Weaveworks, Ilya, and myself, we're publishing a blog post around that topic that also does a walk through comparing different tools there. Now the main thing in terms of observability. Here on the right hand side, a couple of representative or most important tools in that space. In a sense, in our context, you can think of observability as a kind of umbrella term for monitoring, logging, and distributed tracing. I'm going to go into greater detail with each of those, but in a sense, so far, in monolith setup or whatever, you would treat these things, especially monitoring and logging, as an ops responsibility, and you as a developer would maybe be aware of logging or whatever, typically not really of monitoring, and distributed tracing being a very new thing around here. But in terms of microservices, it's pretty much necessary. Let's have a look at monitoring. Again, this is on a conceptual level, and there are different ways to approach that, but essentially what it boils down to is you have a node, VM or whatever, where your containers run. You have the container, then doesn't really matter if in context of Kubernetes, if that is a pod where the containers run. You have something where the isolation takes place. And you have your app or service code itself. So these are the three layers that you might want to or have to typically monitor. And you can argue that different layers are interesting for different people. So maybe the cluster administrator in Kubernetes will mainly keep an eye on the node level, so the overall health, is there enough disk space on it, what's the overutilization in terms of CPU and RAM, and so on. And maybe also on the container runtime level. And you as a developer might focus mainly on the application level, for example. At the end of the day, you need to somehow get all the metrics out there, and you have something called on an abstract level event router, and whoever is familiar with that symbol here, that's Prometheus, which you could argue is more or less same as Kubernetes for container orchestration, is more or less the standard in that monitoring realm. And then what you typically do with it are three things. You can either display it on a dashboard, so for example Grafana. You can create alerts. You can say, for example, for an admin, it might be interesting to see, okay, if 80% of the disk space is used up, maybe give me an alert. And you can, or typically do, store that as well, so that you can also look at the metrics from a historic perspective, so that you say, okay, let's see, have a look at the last year or whatever. But in terms of dashboard and alerts, you would probably only look at the last, I don't know, days or whatever. Any questions so far? Okay. Logging, you pretty much have the same setup. So you have logs that are host or node level, or what is going on between different nodes. You have logs around the container runtime, and you have logs on the application level. And again, depending on the setup, you might only be interested in a certain level. For example, in Kubernetes, it's a good practice to have a namespace administrator looking after a concrete Kubernetes namespace, and there you might look at both service and container level logs. The main challenge there is that given that you have multiple containers running more or less the same code, modulo certain configuration changes, you not only have to look at a certain container log output, but you potentially also need to aggregate logs together. And for example, elk stack or EFK stack using Fluentd rather than Logstash is a way to get these logs together. Unfortunately, Kubernetes is currently not, it doesn't really have a built-in way to aggregate logs across different pods built in. To me, in the context of developers, the most exciting and also interesting bit is certainly distributed tracing. And if you think about it, where it comes from, it's essentially at a certain point in time, if you want to understand what's going on, and that's kind of what people typically call a poor person's tracing. You have logs from different containers, let's say, on different nodes, and you're trying to synchronize them based on the timestamps. That's typically not a good idea because the time is skewed, so you can't really match them up. But that's essentially where conceptually the idea comes from, that you're able to correlate things on different nodes, and then from bottom up essentially get a picture of what exactly a request does touching different microservices. In tracing, and OpenTracing being the standard, and that's one of the most important bits, that nowadays there are different tools, but essentially as long as they're OpenTracing compliant, you don't really need to worry about. It's then more a preference of the UI or other features that makes you pick the one over the other. But the basic idea there is that every request that comes in, and there is always some front-end user-facing microservice, gets an ID, and that ID is passed throughout all the microservices. So you don't really look at timestamps, you only look at that ID, and with that you're able, or such a tracing tool like in this case Zipkin or Jaeger, is then able to piece these different traces together and give you an overview how it looks like. And we're going to have a look at that in the demo as well. And in my understanding, if you're serious about that, if you have a non-trivial number of microservices, I would argue it's a must-have. So it's not some optional thing that you can consider doing at a certain point in time, but you really want your developers to have access to that. And the main question is really just how do you actually deploy that, operationalize that? Do you, for example, leverage a service mesh like Istio, where you get that more or less for free, or do you do it on your own or whatever? But that's, in my experience, the only question. It should not be a question, should we be doing that, just how we should best do that. Okay, and now it's demo time, which is actually nice. that we're getting there so fast. So the first example that I've prepared is essentially what I would call a minimal microservices-based app. Two microservices, the one written in Go, the other one written in Node.js. The domain is the stock market. StockGen obviously generates stocks, and StockCon consumes that. And overall, the setup looks like that. Stock generator spits out some JSON here on a certain port and a certain path. Stock consumer connects to that other service and provides an average, a moving average in this case. So each of those run in their respective pods, and there's a deployment that makes sure that these pods get scheduled on nodes, and there's for each of those is a service so that the communication and service discovery is also granted. Any questions regarding this app? It's easy enough to understand in one go. Right? So the first step is we're going to deploy that, and I intentionally introduced two mistakes. So that could be due to someone fat-fingering something, or there might be a miscommunication or a newbie error. It doesn't matter how these things are, where they come from. The main thing is that these two errors that I'm going to show you, they are literally the top two things that I have either seen myself on Stack Overflow or answering. So these are really, they look trivial once you know what it is about, and they're trivial to fix. But it's really hard, especially if you're not that familiar with Kubernetes and or Docker, to actually figure out what's going on there. Okay, so let me quickly get another one here. So this is what we have. The wrong one. Yep. So I've just cloned the this repo here, right, as a preparation. So you can, if you want to, you can try it out yourself on GitHub here. So that's the content there, and so we have. Can you actually see it, or should we maybe switch off the light here? Would that be a possibility? Because I think the contrast here, if we could switch off these two lights, I think it would be easier to read. I can still enlarge it, but I think. Yes, perfect. That's perfect. Wonderful. Can you see it in the back? Okay. Okay, so we have these two directories, StockGen and StockCon, and we gonna deploy that, right? Let me quickly get rid of that one here. So here I'm just gonna keep a watch. So I just say, hey, list me all the deployments and pods and services in this namespace DOK. And DOK stands for developing on Kubernetes, right? Okay, so I'm gonna deploy the stock generator stuff. Okay, created the deployment, created the service, coming up, ready. So we have the deployment. That deployment has spawned in the supervising one pod, and with a service as well, serving a port 9999. Okay, so far everything fine. Now the second part, the stock consumer coming up, and there we will see that something goes wrong. So we're just waiting for it to come up. Boom, first error, right? Just says error image pull. Okay, what's wrong? Anyone, any kind of idea? So I'm gonna put that away for now. That doesn't change. So I'm gonna focus on this one here.
Docker login.
Sorry?
Docker login. You need to log into your image repository.
No, it's a public one. It's not. The problem is not that it's. Sorry. Maybe I show you the.
That doesn't exist. The image.
Okay. Right. I heard a few really good things. So this is the deployment and this is the service, right? I heard two things. Maybe the image doesn't exist and check the logs. You probably have suggested maybe the image doesn't exist because you're already a little bit familiar with Docker and or Kubernetes. Who said that? Yes, okay. So let's have a look at that, right? Let's say get pods, and of course I need to say in the namespace DOK. I just aliased K to kubectl because it's quicker to type. So we're looking at this pod here, right? That is the thing we're interested in. So let's just describe it. Right? Let's say minus n DOK describe pod and then this fellow here, right? So a good way to, if you have no clue what's going on, is to say, well, describe, give me your state. I could also look at the status or at the logs or whatever, but as a first glance, I'm gonna just look at with describe at a very high level. And what you get is events that are related to that pod, and I see here that apparently this image that I have here, stockcon with the tag 04, it said failed to pull that image. So that is a pretty good indicator that something has gone wrong. I wouldn't be able to look at the logs at the current point in time because the container is not running yet. But this at least if you're familiar with how Docker works, that image doesn't exist. Okay. Let's change that. Let's fix that first thing, and do apply again. And with that, oops, I can just leave. Let's do it like that. I'm just going to apply that again. And with apply, essentially, Kubernetes looks at the previous state, the current state on disk, and the state in the cluster, and figures out what has changed. And apparently, so far, we have only changed that one image. The other thing that also will happen is because we changed the image, it will trigger a new deployment. So you see here it says service unchanged. We didn't change anything in service, and the deployment is configured. Here you see that the new pod has started, and that fixed that issue, right? Now, now I'm trying to essentially get the whole thing to work. So the communication. So both of these pods, both of these applications are up. Let's forward the service that runs on the stockcon to my local machine so that I can curl it from here. I have a forward. That's that, and I need a new one here. Let's curl local host 9898. I think that was average, right? Watch. Nope. So the health endpoint works, but the other one, which I don't know by heart anymore, but where was that? Average. That, if I did it right, wrong, right, whatever, if I introduced the mistake correctly, doesn't give me anything. And that means the application seems healthy, the health endpoint returns to 100, but there is no output there. And I need to figure out why that is the case. So apparently, if you look back at that slide deck here, where we are currently is, we know both of those are running, but since I don't see anything here, that's what I just did with the cur, there must be something wrong in that connection, right? It apparently can't really get the data from StockGen to do that moving average. So how do we figure out about that? Let's check here. So we have StockGen running on port 9999 and StockCon on port 80. That's fine, that's what we forwarded there. port forwarded there. So something here in that service is not running correctly. The first thing I'm going to try is I'm launching a jump pod, and from within the cluster I'm trying to directly get to this service from that jump pod. Let me see, I think I have the jump pod somewhere here prepared. There you go. So that is just a one-shot pod that has curl installed. Essentially, it's just a minimal Alpine image there. So I can now say curl stock gen. So now I'm actually within the cluster, and I can use the default Kubernetes service discovery mechanism to talk with the stock gen service. And that was port 9999, and I think it was stock data. That's me being stupid because it runs in a different node. Yeah, I didn't. So the problem was that was not part of the demo. I should have either launched the jump pod also in the DOK namespace, or since I'm running the default namespace here, I need to actually specify .dok. So if you're in the same namespace, you can just get to any service via its service name, or if you're in a different one, you need to also specify the namespace there. So apparently, if I'm in the pod and I'm directly going there, I can get to that. So we have figured out that the stuff that comes out of the stock generator actually works. So it must be something on the other side. It must be something on the stock side or a communication issue. But let's for now not assume a communication issue somewhere, but really something going on there. So just exit out here again. Let's describe the service here. So kubectl. Where do we have to describe? There you go. The service stockcon. Oops. Stockcon. And there we see, okay, it's on that endpoint, that's all fine. I don't really see anything that's related to this other stock generator wiring. But I can have a look at it in the YAML output, in the status and so on, using that. Output YAML. And there, well, you don't really see it nicely there either. No, because it's not in the service, but in the deployment. That's fine. Okay. And let's do that less. Okay, so the configuration here is, and that's essentially the wiring where I tell stockcon where to find the stock generator. The name of the service is here stockgen, and the port is 990. And that is the issue, because stockgen is actually running on 9999. So let's change that as well. And hopefully, once we've changed that, and again apply the change there. Oops. Apply stockcon. Where am I? Okay. In the right path, hopefully. And now I apply it. So now this time it says, that is actually funny. Why does it? Oh yeah, the deployment, sorry. We changed the deployment. But it doesn't trigger a new deployment because it's only an environment variable change. And let's keep an eye on the Hello. I'm in another one. Okay. What was that? Anyways. I'm now in. What was that? So I mistyped and I'm now in a new window here. And that's a bit like VI, right? Nope. Select. Close window. Where is close window? Okay, okay, that helps. 0. Okay, back here. Sorry for that. So we have changed that, and 999. That's what I wanted to see there, right? That's there. Okay. And now, if the port forwarding is still running, and that means that if I'm now trying to do this, I still get empty. Okay, the new pod is there. Okay, I need to do the port forward again. Okay. And now, yay, fixed it. So now we've fixed both issues there. Now I'm not saying that the way I've presented it here is the best practice to, essentially assume something and then directly jump into that. You probably want to do that a little bit more structured. But essentially, it boils down to looking at logs and trying out certain hypotheses. For example, the one that we had here that you can connect to a certain service or whatever, and then essentially applying the new state and figuring out if it works or not. So that was the fixing the microservices or debugging the microservices part. And now we can get rid of that and that. We don't need that anymore. Yes. And we leave that running. I don't really care about that for now. The second one is around distributed tracing. And for that, we're going to use Jaeger. Jaeger is or was written initially by Uber, and given that Uber is dealing with cars and taxis, you would probably not be very surprised if you see their example application that they have there. So let's start that here. Hot rod, which if we look at it in a moment, we will see what it is. I think it was 8080. And that looks a lot like something you might be familiar with if you have been using Uber, rides on demand. That's what the ROD stands for. And then we are starting up Jaeger here. Okay, I obviously need to start Docker on my desktop to make that work. And we can stop Minikube for now. Don't need that anymore. Okay. And that was on port. This one here. Okay. Now, that is Jaeger, distributed tracing. And currently there is not anything there yet because I haven't used anything here. So let's just simulate a couple of people hailing a cab. And it also ingests certain errors in there and so on. And you will see that that Jaeger essentially picks up the services as they come in. So there are a couple of services there. There's the customer service, driver, front end, Jaeger query, MySQL, Redis, and so on. You can have a look at the dependencies. That's quite nice. I mean, for a handful, it's kind of like, yeah, it might be obvious. But if you have like 20, 30, 40, it might not be obvious at all how they're communicating. And that is what Jaeger discovers for you in real time. It sees, traffic comes in front end. That might not be that obvious, but you see it as it's the route here. And then it calls out, the front end calls out to 3 different other microservices, route, customer, and driver. And that in turn also, each of them has a data store there. And now we're in a position to say, let's have a look at the entire system. So let's have a look at the front end there. And for now, let's just look at all the operations in the last hour, last minute, doesn't matter in our case, find the traces. Here you got a very high level overview. You've got the duration plot here over time, and you've got essentially a summary of how different operations are going. So you have 50 spans within that trace and 2 errors there, and you see the distribution in terms of the microservices. That's nice, but the more interesting view is when you drill in. And whoever did this in the browser and then looked at this view here is probably familiar with that. You got on a very high level the entire call graph, and then you can zoom in. So you see, okay, the front end overall, it took almost 700 milliseconds, and then you see where exactly in your application or in which microservice how much time is spent. Right? So you can immediately spot, and you can go in there anywhere and say, okay, let's zoom in here or whatever. So it's very, very easy to pinpoint. What was that? That was no other way around. It has a very nice keyboard settings there. It's very intuitive, especially for developers, to look at that and figure out where exactly in the call chain things go wrong, an error has occurred, which of the microservices causes certain delays, and so on. So that gives you a very quick way to understand, and a request comes in from the outside world and then spends in the respective microservice a certain time with a certain operation. So you always see, in this case, it's HTTP GET on the route, and there could be puts and so on and so forth. And it's very intuitive. And you can then even further zoom in and see exactly what this request is about and understand what's going on here. And the main point is that the effort in terms of what the developer had to put in there is basically 0. So as soon as from the operation side someone installs that and makes it available, you can just go in there and have a look at your stuff. And that is pretty much, and you can believe me when I say that, your only chance to survive if you have, as I said, a non-trivial amount of microservices. And a couple of resources if you're interested in that topic. A couple of books there from left to right, very high level to more hands-on. I've written this Kubernetes cookbook recently with a colleague of mine from Vietnam, if you're interested there. And a couple of resources that for each of these topics in terms of observability, charity, and I'm not sure her name, I keep forgetting her name, but both of them are excellent. They have an ops background and they focus a lot on observability. That is more on the logging area and around Kubernetes kubectl level troubleshooting. I have this one resource there put together. Okay, with that I'm done. I think pretty much on time. So if there is a question or two, I think we can still do that, or are we over time already? Are we good for a question or two, or? Yeah? Okay, cool. So if anyone has a question, then speak up now. or wait for the break and we can talk with a pizza in our mouth. That's also fine. Yeah?
I have one question. From what I've read, the distributed tracing adds some overhead performance line.
Yeah.
So at what level would you suggest to, or what should you trace and what should you not?
So I'm really convinced that you should be tracing everything, because there is like, yeah, you might incur maybe a few percentage in terms of the delays or overhead or resources or whatever, but it's worth it. You have the full insight. It's really otherwise like driving blind or blindfolded or whatever. It's not a question to me. It's like this trade-off is totally worth it. And the more microservices you have there, the more it's like, why wouldn't you want to do that? And as I said, many people, and that's where it originally came from, actually trying to do that through looking at the timestamps in the logs and trying to piece that together from this. And as soon as you find yourself doing that, then that's a sure sign that you should be using tracing rather than doing that manually, right? But yeah, yes, it does have this drawback, but in the big picture, that's, to me, it's like, okay, yeah, I'm happy to pay that.